No.
Oh boy. Last 10 minutes did not. Okay. All right. So what are you going to do then? So we are going to build the same front end and back end on the same EC2, but in this case, we are going to install the Docker. It's a software, open source software we are going to install, and then we are going to actually make the Docker file, build the Docker file, and then we will be running the same application. And you will be seeing it's running different way.
Yep. So basically, now what we just going to do is just following this step that is shown in this picture. I hope you guys can see it. So here you can see we have some terms like containers, images, Docker daemon, and client registry. So I want to just clarify all those things in just some short terms. Like first, we need to know what is containers in Docker. So mainly it is a lightweight and standalone software packages which include everything to run a piece of software, including code, runtime libraries, system tools, everything that is inside that containers. And then we have images in Docker. That is mainly the read-only templates used to create containers, and images can be built from that Docker files. We have to create some Docker file, which is a text file that containing a series of instructions. That means when we deploy anything in Docker, first we need to create a Docker file, and that file contains some series of instructions that how to build an image. So it defines the application's environment and dependencies. And here you can see a registry. A registry can be said as a Docker hub, which is a cloud-based based repository where Docker users can create, test, store, or distribute container images. So this is the mainly client side where we have our CLI, that means command line interface, from where we can give the instruction like Docker build, Docker put, pull. These are mainly the instructions.
So
And
call the
Docker
Docker
daemon,
API. So basically, it's called all the API call, and
yeah,
making all the API call the Docker host, which is the Docker daemon.
yeah. And Docker daemon is a core component of Docker, means mainly this one. So this is a core component, and this is responsible for managing Docker objects such a like images and containers and registries. So it mainly like pull all the API requests and process them and pass it to containers and create the images like using those instructions. So that's how mainly a Docker works. So now we'll see how to do this in real life. So I'll go back to my terminal. So this is my backend. So here first we need to install Docker. So we don't have the Docker in our server. So first we need to install that.
So if you
Before,
type Docker and hit enter, it will say it is not installed. That's
yeah,
the one you know.
yeah, before that, I want to do another thing. Like we have already a Docker file because we have posted in our GitHub. So I will remove this one, the previous one. So now if I do ls-la, so there is no Docker file right now. So now I will install the Docker. For that, the command is sudo apt install docker.io. This command is used for installing Docker. So if I hit enter, now why? Then it will install the Docker. Okay, now we have to create the Docker file where we will write down the instructions. So I have to name it as vim Docker file. Now I'm inside that file, and here I'll write down the instructions. So for that, I have to go first to the insert mode, here is the instruction. So what is this saying? um, there is like from node work directory source app. That means the working directory is slash source slash app, where all the files are there, and it will copy, that means dot means all, it will copy all or everything to this directory, and then it will run npm install. Like you have already if you can remember that what we did first, we install npm and everything, and then we run the npm, or install the npm, then we run npm start. By that we can start our backend application. So we have just write down those things. Now I'll save it, and we have to build this image. I have just created the file, we didn't build the image yet. So for building it, the command is sudo docker build
So basically,
hyphen.
what you are doing exactly what you have done, the bare metal, all the steps, you're doing the same thing, but you created a file. It's called the Docker file. You are exactly following the Docker process. You see this? None of most of the steps is all the Linux command. Most of the steps. Remember, I mentioned Docker is using directly Linux command. So make sure you just pay very close attention.
You can see it is downloading the npm, and from node is pulling the library what we have write inside that file. It is just executing one by one. So we can see it is successfully built and tagged. Now we will see that our images are created successfully or not. For that we have to check the images. So the command is sudo docker images. So here you can see we have our image, which is ecom back hyphen I. I have put that name as it is, and it is the image, and tag is v1. I have write down the version as v1. That's why it is showing the tag as a v1. And it is created 32 seconds ago. That means just now it is created. So now what we have to do, we can tag it like where we want to store it. So we need to store it in our Docker Hub account. So we will tag it with a new name with our Docker Hub account tag. So for that, the command, I'm writing it down.
So you need to create a Docker Hub. It is free as well for you. It has a paid version, and you just the pushing these images to your Docker Hub. So in the every cloud provider, they have their own container storage. AWS has their own, Google has their own, and the Azure, and like pretty much all the cloud provider, they provide their own container storage service.
Yes. So for tagging it, the command is sudo docker tag ecom back I colon v1. That means our image name, and my uh, name for Docker Hub account is
So,
transformation2, and then the image name in which name I want to store it. Now if I do again sudo docker images, you can see another image, this one, which is transformation2 ecom back hyphen I, which we just tagged. So now we have to push that image to our Docker Hub account. And for that, first we need to log into our Docker Hub, which for that, which command is sudo docker login. So here I need to put
So your Docker
my
app
name,
ID.
username first, then the password.
In Linux operating system, anytime you type any password, you will not see. This is the one of the privacy of the Linux. So
And
login succeeded. Yep.
yeah, it is successfully logged in. Now I will push that sudo docker push and the image name, which is this one. Colon v1, the version. So I want to push it. And now I log into my Docker Hub account to see it is updated or not. Okay, we can see it is pushed. So let's go to my account. So yeah, this is the latest image which we have just pushed right now, ecom back hyphen I, and less than a minute last pushed. So you can see our backend image is now pushed on our Docker Hub account. Okay, now we will run the newly built Docker image with port forwarding and in a detached mode. So we have created the Docker image, but we need to run it to see or to run it on our server. For that, the command is sudo docker run -d for detached, p for port. So we are using 5000 port for backend.
So this is the important command, the run d, which is fine, detach and port. So remember, the Docker use the operating system, the port number, operating system resources. So the left side is the operating system port number and right side is the Docker, that is specific application container port number. So you have to know this. Again, left side is the host, the port number, and right side is the Docker application, the application we are building now, that port number. So
So
application is
yes, now you can see our application is running and the container ID is this one. So we have to check that our application is successfully running or not. So let's go to the browser again.
same IP, but we
So
just
this is the same IP because we are using the same server. I'm just reloading it.
so you see,
So you can see
probably you will get confused, right? No, it's not true. You guys are faking it, right? Let's go back to the contain the console and change the Docker port number. It will work as long as you are not changing the whatever is called the host port. You're good. Means you can put any Docker port, you can put it. So you can rerun it. You can close. You can shut down it.
this image.
Yes, you can just
Uh,
kill it.
okay, should I run it in another port?
Sure. Yeah. That's my point. Yes. So now we are changing the, yeah, just 1000. As long as the port is available, you're good. Okay. So now, because existing is running, you have to make some changes. Yep. Nope. You have to stop one. It's running one. Port is already, so 1000 is
Okay, it is
already
already bind in 5000 port.
right, because this is the one I was talking. So the once one port, you have to stop that fully. So fully stop the Docker, kill it. See this? So you on this port number, you cannot use any other app at this moment because you see this is live example. But the what I wanted to show, like you have to kill fully, right? Okay.
Or we have to kill it otherwise.
It's not going to work also.
Yeah.
Okay. So what is the purpose is you cannot use the port more than once for any of the application. and you cannot expose the same port for multiple application, one to one, because the port number has to be unique. So you can, the reason we are doing it, so you can Docker kill it. Docker kill means, of course, you're in the Docker platform now. You're in the exactly in the Docker. You're not in the operating system anymore. So Docker has all this run. Docker push means pushing something. Docker pull, you're downloading something. Docker PS means you're seeing all the processes running. Docker kill, right? You're seeing exactly the killing a specific, the images, all of these things. Beside the Docker, all other actually the Linux command. All other Linux command. PS is the Linux command. The Docker kill is the Linux command. Basically, all this Linux command. So how the Docker works? Docker works simple way. When the container is running, container the need a port, and the container port is mapped with the host port. Host port is 5,000, right?
Mhm.
How that works now? When go back to your browser quickly. So now know the workflow now. Go. Yep, yep, go. So you see this? So when they, you see this, you are using the exactly 5,000 because you, as a customer, you always hit the host port, which is the left side 5,000. And then because it's under the hood, the Docker actually routing to the Docker port, means the application port. In this case, of course, we put it 5,000. If you put 1,000, then it will be routing to the 1,000 port. That's how it works. The customer is coming to your browser, like you guys are coming to browser. So you are typing our port, like the host port. Host port is actually rerouting to the Docker port, which is you can do anything you want. All right. Yep. Go ahead.
Okay, let me show the front end now. Like, let
Yes.
me create the front end images now.
So at this moment, your backend is ready to go. So each
Yeah,
time,
our backend is ready.
developer the go back to her question, you can go ahead. Each time developer make the changes, you have to build the Docker file again, and it will get it accommodate the new changes, right? How to do this? You can do two way. You can do directly on the cloud, your cloud server, but that's not the best practice. The cloud ops engineer build the whole process in the developer computer. Developer actually can do their own, or you can do directly on the your build server, which is on the Jenkins. There is many scenario, but we are not going to cover all this in depth here. That's exactly who does the bootcamp. They know all the details. So when you do the uh, developer does it, they actually the build and their machine, and once they build it, they can push it. After the push, and then it goes to the Docker Hub, and then from your cloud's environment, with the cloud machine, you are actually pulling the image and you run it. The entire process, manual steps, the DevOps engineer make a pipeline, and that's called the kind of the CI, or you can call the CI/CD. When not the true statement, CI/CD means it is in depth, but you can call the short version of the CI/CD. It means the moment the developer write the code, will be built, code will be like the Dockerized, code will be pushed, code will be pushed all the way to the any container storage like the Docker Hub or the Google or the AWS, and then it will be pulling the image onto the environment, which is the test staging or the another any environment, and it will actually run. So that's entire things is fully automated, so that the your DevOps engineer has not DevOps engineer does not need to do anything manually over and over. So the main tension actually the build the Docker file. So anything you do the Docker, everything you have to create the Docker file in the same directory where your code base is. Make sure you know this. So she has been doing all of this. If your code base is one place, Docker file in another place is not going to work. It has to be on the same. And before you do the Docker anything, right, you have to install the Docker, make sure the Docker installed correctly. So you have to go to the ecom 1, right? Or no, ecom 2. You have to go to the front end, right? Did you go to
Yes,
the front?
I'm in the front end. Yeah, I'm in the front end. So here is the like Dockerfile parse error on line 6. So it throw a error while while executing the file. So what I will do, that it has some error that is mainly for space issue. So here we can use our ChatGPT. So I will copy all the content.
Did you go
This
over the
have,
Docker file?
sorry.
Did you go over the Docker file, each of the line you did, right?
Yeah. But as I copied it from the slide, that's why some extra spaces might be here.
Yep.
So it happens in our deployment scenario, but we can use ChatGPT for that. Like if I paste it and write it, correct the indentation of this file. So it will remove the indentation, like the extra spaces while we copy something. Sometimes extra spaces insert in the file. So we can use ChatGPT for that, for removing those things.
So it not only give you the code, but also it gave you the comment as well.
Comment as well, like which line is used for what.
It's very important. AI is the power, right?
So now we can again build the image.
You see that the magic? So the machine helps you when you did your part, and machine will be fixing the things. So it is building the front end now. So if Farah pushed the write the new code, we have to do the same thing again. If the backend engineer write the code, we have to build the backend image again. So this is actually the regular work. Okay, so Docker file is nothing but like you install the Docker the npm, that then you copy everything else, and then you start running. You do the cmd. It's everything actually the Linux command, because Docker daemon directly accessing all the Linux command, because that's the benefits of the Docker. So it is building the front end always takes longer time, longer build time than the back end. We discuss about this many times, but you learn one more time why. Because the back end does not have any like the beautification or any like a the graphical library like the front end has. Front end has HTML, CSS, and many other library. So front end always become the bulky, right? A lot of makeup kind of things. The back end doesn't have any of this. So backend build always faster than the front end. It is the fundamental regardless of any application you build. All right, it's done, right?
Mhm.
Okay. Next build.
We have to wait a little bit more.
Okay.
Okay, now we'll run this image on 4000 port. Okay, now we'll push that, like the backend one, to our Docker hub. So sudo docker push and then the image name.
Yep. Second, from the local your machine, you're pushing to the Docker Hub, which is the image storage. It's exactly like a stuff like that.
And this one is our frontend one. So let's see, it is running or not. Yes, now it comes like uh, the frontend is now here, as it was down, but we has run it through Docker and Docker images. So it is now running on 4000 port, and our backend is also connected with this frontend.
Yeah, that is correct. So now you are now
And
Before you
We
go
have
to the bare metal,
already pushed our image to the Docker Hub. So let's go to the Docker Hub and reload this one. So we can see less than a minute ago, our Docker Hub frontend is pushed to our Docker Hub account. So that's how mainly Docker and Docker Hub works. And we can publish or we can like deploy any of our application in Docker in this way.
basically each time the version is important. Each time developer is the getting the new code to follow the user story in the sprint, the new version we put the new tag. Tag is nothing but the new version, which is very important. Anything else to cover?
Um, that's all for Docker and Docker Hub. The next one is Docker Compose and Docker Swarm. We can have a break for 5 minutes and then we can start again.
You
Let
can
me
stop
prepare
the
the
screen.
machine in between this 5 minutes.
You can stop the screen.
Yes, sure.
Yes, I can go over the. Okay. I go here a little bit. So
In between that time, we can describe the Docker Compose and Docker
okay.
Swarm theory part.
Yep. Okay. So we did so far. So this is exactly the scenario now. Let's go here. So we build the Docker file. It is important exactly all the Linux command basically. Install the Docker and create a Docker file on the code directory. Remember all of this wording, very important, right? And then after the image, basically all the bare metal command. Okay, and nothing is different. And of course, you always build the bare metal one to become familiar, best practices. Then you can build the Docker file. You build an image, you did it, run a container, and the test and iterate, push to the Docker Hub, we did it, and deploy and production. Test and iterate, it means that you sprint, means you are working every day, and then you build it, you test it. Again, you are pushing the bug, you're fixing, and you build it, you push it, you test it. That's the same thing is called. But as of now, everything is as expected. It's like a single entity, and it's just working. As of now, that's the case. It is just working. We build the two Docker images. One is the front end, one is the back end, which is needed, and we run it. It is just working as expected, as fine. And we had the virtual machine. EC2 is called the virtual machine, basically. On this virtual machine, we install the Docker, and we actually build the front end file, we build the backend file. How we build it? Because we had already code base on the same machine. That's the reason we did not went to the Git and we did not run the code. But behind the scene, if you do from the scratch, you have to do the same thing the way you did the bare metal, right? You have to go to you have to run the Docker pool or Git clone, and you have to build the Docker file and do all the things like this step by step. But since we have already the code base, so in each of the code base, we have a two Docker file. We build the Docker file, and we run the container, and we have running on the front end and the back end as expected. This is called the single entity, right? It's all good. And Docker exactly install on the virtual machine. And the question is, you did not ask, well, there is a question. Can an application run without operating system? Answer is no. Okay? Answer is no. You cannot. Operating system is the media between your notepad and the hardware. Who is the media? Operating system. So now you can say, well, how that happened then? How this the Node.js application is running on the Docker? Where is the operating system is? Well, that's the math. Because on the Docker image, it is very little operating system is already there. So once you actually join the bootcamp, you learn the very details how you can inspect in this image. You actually go in the file, because that version is very minimum version. Because remember, I said it. One of the main thing Docker solved, that you are cut down the tons of millions of dollars for the companies because you are not putting gigantic operating system for each app. You are putting little bit of the operating system in each of the Docker images. That's how it works. So you can inspect it. You can see what if the IP address has been taken, how that is behaving. That operating system has nothing, basically nothing. It's very minimum. Can you install anything? You can. That's the part of your actually the core job. This is actually the show and tell basically. Surface level, but the core DevOps engineer, they go each of these, the images go into the details, do the debugging and see why it is not working, what is working. But the fundamentally, tag is important because tag comes with the developer. Tag come with the developer because developer is continue pushing. Why developer is pushing? Because they're in the sprint. Why in the sprint? Because we are in the software development team. Why we're in the software development team? Because we have to build an application for the business. So nothing is actually the going away. Everything is there. So tag is nothing but exactly the versioning, which is important part of the your process. So your Git versioning is important. The Docker tag versioning is important. They're all staying as expected. Okay, so let's go here.